In this video, I'll be teaching you guys about built-in functions. So what are built-in functions? They're just functions that come with Python, alright? In the previous video, I talked about regular functions that you can make by yourself, but there's also functions in Python that do things for you that the creators were also generous to make beforehand so that you don't have to make them yourself. A couple examples would be typecasting, length, absolute value, and input. And we're going to cover a little bit more than that today, but I just want to show you as many features as possible in the shortest amount of time. Let's talk about typecasting. I've already talked about a little bit about typecasting before, but let's say that you have a string, and that string was 60. If you wanted to print out 60, you could simply write down print string, correct? Well, here's the thing about this. What if you wanted to do math with this? What if you want to do 60 plus 7? All right. What's going to happen is that you're going to have a string here. The Python is going to think, you want to concatenate with this plus, right? Usually if you have a string and you put plus, you want to concatenate two strings. But here's the issue. You cannot concatenate a string with an integer. It's a very common error that a lot of beginners make, that I made when I first started coding. But you'll get the hang of it, of course. But what you can actually do is turn the string into an integer. And then you can now add 60 plus 7. So this string, 60, becomes the data type integer. It's no longer a string. And now you can add 60 plus 7 and you won't get an error. So you can see why typecasting could be helpful in some cases. You could also, let's say, turn this 7 into a string using typecasting, and now you can concatenate these two strings. So if you want to concatenate 60 and you want to concatenate 7, you get 607, right? That's simply adding the two strings together, 60 and 7, right? So this could work as well. You can use typecasting for strings. What you can also do is turn, let's say, things into a float. All right. You can also turn things into booleans as well. But let's talk about the potential errors that you might run into while doing so. So let's say you want to concatenate this string into. Let's actually turn this into x now because I don't want to call it string anymore. Let's say you want to turn x into, it has some decimal places, into an integer. This will not work. Oops, why did that move? This will not work. You're going to get an error. All right, your string needs to be of some number base 10, which just means it has to be in. If you don't understand that math terminology that well, it just means that you need integer in here. All right, you need 61. All right, 605 could work. All right, but the moment you put a decimal place, simply will not work. All right, so you cannot have this decimal place. It is not good for using the int typecast method. Not method, the function. If you also want to use int, let's say you don't have a string anymore. Let's say you simply have a float. All right, and this float is some long decimal. If you want to turn this to an integer, what's going to happen? Well, you're not going to get an error, all right, this time. You're not going to get an error. The error only happens when you have a string, a number inside of a string. This time you have float data type. So this float data type, what's going to happen is if you turn something into an integer, it truncates. It truncates the decimal places. So let's say we have 615.74, blah, blah, blah. The reason why I put 7 here is because it's an example of not rounding up. Int does not round. All right, you do not round with int. What happens with int? Oh, my neck. Oh my God, that hurts. Oh, I like slept wrong, and now my neck hurts. Okay, what happens with int when you use the int built-in function or the int typecast is that it truncates a decimal place. So all it does is just remove every single decimal place and then turns your float into an integer. So anything to the right of your integer, it's gone. Python doesn't care about that anymore when you use int like that. And if you also want to double check your type, like your data type, you can write down type with your variable. So in this case, since x is a float here, what's going to happen is that you get the class float. If let's say x was a string, your type would output string. So this is pretty useful in some cases if you wanted to, filter out data types and stuff like that. Now, how about if you want to turn integer into a float? You might be wondering that. Well, you could turn integer into a float, print, by just writing down float with the variable name inside of this built-in function, and you just get a float. Now here's the thing about float. Doesn't add any cool extra decimal place. It doesn't add some random numbers. All it really does, put an R in there, but all it really does is just put a 0.0 after it. So float, really nothing special, but float could be useful in some cases, especially when it comes to division and math with coding. Math coding is a little bit different than what you're going to be used to, especially if you're not coding in C. Especially if you're not coding in Python. If you're coding in like lower level languages like C, geez, man, some of this stuff is annoying to learn all the rules for. But float can be helpful in some cases. Just keep this in mind. You can also write down Boolean. Let's say you had where number 1 bool is your typecast function. What happens if you turn 1 into true? If you have 0, what are you going to assume? What's the other Boolean? It's false, right? So 0 just stands for true. False stands for... No, 0 stands for false. True stands for 1. All right. And let's say you had 5. It's going to automatically output true. Anything other than 0, say -1. Yeah, anything other than 0 will just be false. Oh my god. Anything other than 0 will just be true. All right. We had 0 here. You get false when you typecast x into a Boolean. And anything other than 0, random number, you get true. All right. Just keep that in mind. Now, let's say you get the string 1. What are you guys expecting when you turn this into a Boolean? You get true. What if you had a big fat number string? You get true. Now, what if you put 0? What are you guys expecting? Well, that's not what you expect. You get true. So if you turn a string into a Boolean, any single time the string has anything in the string, you will get true. If the string is completely empty, that's the only time you get false. If you have a space, you get true. If your string is empty, you get false. So the only time you get false for a Boolean, if you're typecasting a string into a Boolean, is if the string is empty. All right, keep that in mind. Let's talk about another built-in function called length. Let's say you had a list. Now, I haven't talked about list yet, but list I'll cover it more in depth in the video. But basically, what a list does is just store a bunch of values. Right? Let's say numbers. You have the string hello. All right. So if you wanted to figure out the length of this list, the amount of values inside of it, you could simply write down length and then the variable that stores the list. 3, right? So this length can be really useful, especially if you have dynamic programs that have different list lengths and you need to constantly adjust all your code so that it fits specifically for that list. So if I want to keep adding values, say bigger number, right? You have 4 values inside this list, right? 1, 2, 3, 4. All right. Keep adding more and more. Maybe put a string in here. Again, you have 1, 2, 3, 4, 5, 6, 7. So I'm expecting 7 on the output. So length could be pretty useful for dynamic programs. But I'll cover that very little in this video. Let's talk about absolute value. Let's say you had a number, -5. If you print out num, you should get -5, right? Well, absolute value is pretty self-explanatory. It just gives you the absolute value of your number. So if you have -5, you get +5. If you have negative big number, you get the positive of that bigger number. All right. And if you have a positive number, of course, if you take the absolute value of a positive number, you just get a positive number again. Now, keep in mind this works with floats as well. If you have an integer, absolute value gives you back an integer. If you have a float, it will give you back a float. So the absolute value keeps the same data type, whether or not it's an integer or a float. Now, here's something for you more complex number guys right there. Let's say you had a complex number. If you don't know about complex numbers, you can ignore this. Let's say you had a complex number, let's say 3 and 4, because that's easy to do. If you had a complex number 3 plus 4j, basically what absolute value does is return the magnitude of your complex number. So 5 in this case. All right. So the magnitude of 3 plus 4j is 5. Pythagorean theorem, 3 squared plus 4 squared, square rooted, right? You get 5. That's enough about absolute value. Let's go ahead and talk about round. Let's talk about round this time. So let's say you had 5.4. What round does is round, right? So if you wanted to round the number, you put round num. So you get 5. Here's the thing about this. If you have 5.5, you'd expect 6. You get 6. But what if you had 4.5? Well, if you had 4.5, you round down. Why is that? Well, what round does is round to the nearest even number if you have a 0.5 in your decimal place. So if you have a 0.5, rounds to nearest even number. So what does this mean? Well, what this means is that 2.5 rounds to 2. But 7.5 rounds to 8. Oops, that's the wrong symbol. 7.5 rounds to 8. So 2.5 rounds to 2, 7.5 round to 8. All right, so keep that in mind. You round to the nearest even number if you have a 0.5 in your decimal place. So if you have a 7.5, rounds to 8, 2.5 rounds to 2. Little more examples maybe for you guys to build your neural network. 5.5 rounds to 6. And 1.5, actually, no, 3.5, no, that's wrong. 9.5. No, 10.5, there you go. Bro, I keep taking bad examples. 10.5 rounds to 10. All right, rounds down in the case of this because the nearest even number is 10, right? 10.5 rounded up is 11. That's not an even number. We just round down. Keep that in mind when you're using round, especially for 0.5 values. This is very important to know. But let's go ahead and talk about binary, actually. If you wanted to represent a number in binary, all you'll need to do is write down bin. In this case, you're going to get an error, but you can't write down binary for a float. Let's go ahead and write down an integer. If you don't know how to count in binary, by the way, I have a video on that. Link will be down below in the description. And also have a video on hexadecimal if you want, because I'm going to talk about the hexadecimal built-in function next. But if you know how to read binary, this right here is exactly what 4 would be in binary. If you had bigger number 10, let's say, 10 in binary would be this. 1, 0, 1, 0. Right? So this makes sense. How about hexadecimal? 10 in hexadecimal is A. That makes sense, right? And you're going to see this 0x and then some numbers after. And for binary, you see 0b. So basically, just typical convention. If you see b or 0b in front of your number, it stands for a binary number, right? And if you see 0x in front of your number, usually this stands for hexadecimal. All right. So keep that in mind. These are just small built-in functions. You're not really going to use binary or hexadecimal that much when you're coding in Python. So, this is just another feature I wanted to show you. But let's talk about input now. This is the most funnest one. Let's say you had a variable x and you had the function input, right? And you wanted to print out x. Well, input calls for an input in your terminal. You can write down an input, and your input could be anything. It could be hello. It could be 5, 6, 7, 8, right? But let's write down hello 5, 6, 7, 8. When you write down hello 5, 6, 7, 8 in a terminal, click enter. It outputs, again, the hello 5, 6, 7, 8. Here's the thing about this. No matter what, your input will be of type string. Right? Whatever you type into the input, it will be of type string. All right. So even if I type down 65, your class is a string for x. All right. So whatever you type into the terminal is what you get for the variable value that you set equal to the input. So what if you want to prompt? Let's say, how old are you? All right. Put a colon in the space. Well, you write down how old are you? Well, you see the question, how old are you in the terminal, and you could type something down after that. Let's say I'm 19. Click enter. You get 19. Here's the thing about this. Again, although 19 is just an integer, x right here saves as 19 because that's what we typed in, and it saves as a string. No matter what, your input will save as a string. So if you wanted to do math with your input, you would have to simply use typecasting. So you can write down int here to input, and then if you write down 19, now your x variable is saved as an integer because I typecasted the input after taking the input. Keep in mind, this is very dangerous because let's say someone types in a word, you're getting an error because you're trying to typecast. You're trying to typecast this input, but input, well, what you typed into the input was a word, and you returned the word. All right, so this right here is very dangerous to do. Usually you would want to set an if statement for this, but it could be pretty fun. Let's say, what's your name, right? If you want to use your input, you can write down Jitty, and the class is a string, and you output Jitty as X, right? So these are pretty cool. You can also use input for more dynamic programs like hello, my name is. You string concatenate this, right? So hello, my name is, if I write down Jitty into the input, into the user input, what you get is hello, my name is Jitty, right? Because I concatenated this string with input. You can also write down multiple inputs. Let's say you had input, how old are you, right? Hello, my name is X, and I am Y years old. So if I wanted to write down name Jitty, and how old are you? 19. Hello, my name is Jitty, and I am 19 years old. So you can write down multiple inputs, but keep in mind, this is very important, whatever you type into the input is what input returns, is what the input function returns, and then whatever it returns, you can set it equal to a variable. So if you don't know what return does, my functions, the video on functions, I have a Python playlist down in the description as well, so you can scroll through that. It's on the third part of that playlist. It's very labeled in very big font in the thumbnail. It's called functions. All right, but if you don't know what return does, it'd be very helpful to know how to understand these built-in functions. Basically, input does is return whatever you typed in, and then you can set a variable equal to that return value, and you can do whatever you want with that variable. So input, very fun in multiple different ways. Let me actually show you something I did with input. So it's just a little showcase. This is a very early program I made in my coding career. So when I first started learning how to code, I did a lot of projects, right, to mess around, which I recommend that you guys do as well. But this is a very poorly coded Hangman attempt. I have a better version now, of course. Like, I made it with significantly more efficiency, my other computer. But what word would you like, Hangman? I'll write down. All right, this is user input. This is an example of user input. And what I did was, let's say I wanted to Hangman Jitty. Okay. How many chances would you give yourself? I'll give myself 6 lives. All right. So you could write down what letter would you like to guess. Let's say I wrote down K. Right. K is not in Jitty. Now I have amount wrong. Well, J. J is in Jitty. Right. J. Right here. And how about I? Right, I is in Jitty. T is in Jitty. Right. What if I guess another one wrong? G. Right. F. If I write down something that's not a guess, please type one letter. Right. So you can do things with user input. You just need to cover all the cases. Let's say I write down 4. Right. Please type one letter. Right. 7. Please type one letter. And the last letter is Y in Jitty that I haven't typed down yet. And since I put Y, the program should end. Okay, it should write down you win. Okay, this is a complete fail. Let me try this again. Hold up. So if I write down, let's say name, chances 5, N-A-M-E. There you go, you win. Right. It should say you win at the end. But the reason why I put what word would you like to choose here is so that someone else could write this down, and then someone else could play it, and they wouldn't know the answer without scrolling up. But this is a super early program that I did. I actually have a Hangman version. That has the actual Hangman in it. So I made the design into the terminal, which took a lot of problem solving at the beginning, especially since I didn't really know that well how to code. But there's a couple cool things that you can do with user input. Hangman is a very good beginner project that you can learn how to do, especially once you learn about conditionals, if statements, for loops, while loops, right? But I just want to showcase that. As always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thank you for watching.